Hi everyone. The following will demonstrate our final EC551 project Duck Hunt on an FPGA. My name is Juan C. My teammates are Takao Yamada and Esteban Gonzalez. Our high-level block diagram consists of the following. A gun controller, which interfaces with two Nintendo Light Zapper guns, an interface module, which interfaces with onboard push buttons, a game engine, which controls the overall flow of the game, a graphics generator, which provides the location of each of the sprites on the screen, a graphics processor, which obtains the binary of each of the sprites from memory, and a VGA controller, which outputs all the graphics onto a CRT monitor. To start, I will provide a bit of background on how the original Nintendo Light Zapper gun worked. As the player pulls the trigger, the screen transitions from displaying animation to displaying a blank screen for one frame. Then, the screen transitions to a blank screen with one white square in place of the duck. The following frame, the screen transitions to a blank screen once more. Finally, the screen transitions back to displaying animation. If the gun was pointing at the duck, the light detect signal in the gun will register a low-high-low sequence, which corresponds to hit. Otherwise, it is a miss. Attaching the Light Zapper gun to an oscilloscope, we confirmed our findings. On trigger, the screen displays the transition. With the gun pointing at the duck during the transition, the light detect signal registers the sequence. This section of Verilog code is part of the screen sequence generator. The purpose of the code is to generate the black-white-black frame sequence on the monitor so that the gun can detect. The module is a finite state machine separated into three always blocks: combinational, sequential, and output block. The states change from an initial trigger, and the outputs in each state determines the color of the box where the duck was located. The gun we obtained were not authentic Nintendo Light Zapper guns. We had to take apart the guns and determine its schematic. After some investigation, two external pull-up resistors were needed in order for the gun to work properly. Here we have the major components of our project: the CRT monitor, player 1 and player 2 Light Zapper guns, the VHDC breadboard which the guns are connected to, also the Nexus 3 board. Finally, we have a PC to load the bit file into the Spartan 6 FPGA.
To start the game, hit the reset button to take you to the menu screen. Use the player 1 Zapper gun to select either to play in 1-player mode or 2-player mode. I will now explain the concept of the game. I selected player 1 on the menu screen. The goal of the game is to shoot as many ducks using the Zapper gun. Each time a player kills a duck, the player earns 500 points. There are 10 ducks per level, and there are 5 levels. For each duck, the player gets 5 seconds to use up 3 shots. If the player uses up all 3 bullets, the player will no longer be able to kill the duck. When 5 seconds are up, the duck will fly off the screen. The duck comes out of the grass at random positions, moves in unpredictable movements, and it can fly behind the tree to make the game difficult and fun. After 10 ducks, the player moves on to the next level. The ducks move faster at each level, making it more difficult for the player to shoot the duck. We are now playing 2-player mode, and we are at level 5. The duck is moving faster than it was in previous levels. In 2-player mode, each player fights over who can shoot the duck first. The player who kills the duck first earns the 500 points. Each player has 5 seconds to use up 3 shots per duck, otherwise the duck flies off the screen. Whoever has the most points after 5 seconds wins the game. To play again, the player hits the reset button.
What we have here is the test bench for our game engine module. This module controls the game modes, number of players, the scores, the bullets left, and ducks left at the end of each level. The reset signal initializes all the registers. We can see that, initially, each player has 3 bullets and 0 points in score. Also, there are 10 ducks in every level. In this part of the test bench, we can see a trigger signal with no hit signal. When we have a trigger signal with no hit signal, it reduces the number of bullets. The game only allows 3 attempts or 3 bullets per duck. When we have a trigger and a hit signal, we note that a duck was shot. In this case, the game engine reduces the number of ducks left from 10 to 9. It resets the number of bullets to 3 and increases the score of the player that shot the duck.
Some challenges we faced in designing this game was that we hit our BRAM resources very quickly when creating the sprites. We had to use tricks to be able to design everything. For example, we saved the menu screen's logo in half the size, and we used post-processing to double the image. The grass during the gameplay is actually one sprite being duplicated many times to create the whole field on the screen. We flipped the duck's images for the duck to be able to fly left or right. We even had to hard code some of the sprites to reduce the use of the BRAM. Another challenge we faced was the duck's ability to fly behind the tree. To implement this, we had to make a foreground and background. When the duck flies near the tree, if the tree's green leaves and brown branches are not being shown, then we display the duck. When the duck is not being displayed, we display the blue sky.
Thank you for watching.